maybe I didn't say that. I want to give credit to the students that I worked with because they did most of the work, and I'm here just talking about it. And yes, what I wanted to say is that issues in natural language requirements, like in natural language artifacts like requirements, can lead to sometimes higher costs during system specification. And there is a lot of research that has found that natural language requirement contains a rather high degree of bad structure and quality problems, which can influence the cost of developing this. So for these requirements, there's the so-called bad smells have been established. And these are indicators of poorly written natural language artifacts. So these are some examples of bad smells, problems that can appear in natural language requirements. And then they have been discovered through a lot of requirements engineering work. And they were reported actually for a long time as problematic. And this has not improved, I would say. And that shows that there is a need for more tooling and more awareness on this. So ambiguity. Sometimes the problem is that a word or a phrase has two or more different meanings. Vagueness, that's another problem because you have lack of precision and structure, detail. Sometimes the requirements are quite complex, and you need to identify those early on. Sometimes these are metrics that are super simple to measure, but in some other cases is not. Like for example, in the case of untestability or inappropriate implementation, that's not easy to find. So you need techniques, but we are not focusing on all of these problems. We are focusing on the problems that relate to the language aspects. Yes, so yeah, so these are some examples of ambiguous, requirements. The system shall be safe. The requirement says that, and how safe? Safe in what way? The system shall be secure. Okay, that's not really a requirement, maybe. Logic is not always complete. You have the if, but not the else. Sometimes you have incomplete requirements that the problem is that engineers must guess the intentions instead of, having enough information to implement. So like the system shall do X under what condition, when, in what state, what triggers this event, how fast. So there are many aspects here that are important. I want to mention here that what I mean by security requirements. A security requirement is a requirement that has significant security ramifications. That means that it's very interesting because then you can have also other type of requirements that have security ramifications. And I think it's important to consider also those, because you could have functional requirements that have security ramifications. You can have safety requirements that have security ramifications. So you need this is related mainly to the functionality that ensures that you have a certain property of the software being satisfied, or multiple properties and security properties. So I give an example. Verify that no default password in use for the application framework or any components used by the applications. So yeah, it's quite high level, but it's still, very interesting to look at how these are written and how you could use them for testing or for verification. Okay, someone is muted. Can someone mute? You fixed it. Thank you so much. Good. So what we do here, we use NALABS to hunt for problems, quality problems in natural language requirements. And in the scientific literature, these are called smells, because you're basically, smelling that something is wrong. You don't know for sure that something is wrong, but you're smelling it. For example, if you find a requirement that contains vagueness or vague phrases, then that's an indication of something that could be wrong. Doesn't have to be, but in practice, in some cases it is. So we have this kind of metrics related to vagueness, optionality, subjectivity, weakness, automated readability index. And then we have also some other measures related to complexity. So we measure how complex the requirements are. And then you can decide by yourself if, or as an engineer, if these are useful. Yes, so this is how the tool looks like. Actually, we have a version that doesn't work with a graphical user interface because not everyone wants to have this GUI. Yeah, it's basically you have the requirements, and then you have some keywords that are highlighted with a certain color, and then you see how many instances the tool has found of the smells, or you can see how much how high the automated readability index is, for example. That's interesting to some people, or how complex your requirements are. Maybe I can say that for automated readability index, there are a lot of approaches on how to do this. NALABS actually uses a very simple formula used by US military long time ago when they were trying to give, requirements to people working in the military. So they wanted to make sure that they're understandable by, their ordinary Joe. So we use a formula related to the average number of words per sentence and the average number of letters per word. And then you have some type of grading. Yes, so what we've done here, we actually collected data to evaluate this tool. So we looked at artifacts that from different repositories, like GitHub, Zenodo, NLRP, Benchmark, and also we gathered requirements and test specifications from industry. So we wanted to see how the results are for both industrial requirements that are not public and for the ones that are made available to us. First, I would like, even if I mention security requirements, I just want to start that we show some results related to safety requirements that have security ramifications. So this is done work that has been done by Kostadin, and he was mainly looking at complexity of natural language requirements, but we also measured other type of measure other quality problems. So he analyzed 3 requirements documents from 2 different projects. 2 of the requirement documents contain, I think, around 870 requirements, while I think the third one was quite big. Yeah, it says on the slide, 5,700 requirements. So we had quite a lot of requirements, and we found quite a lot of problems in those requirements that have been fixed. And this is these are requirements that were in industry. Yes, so I think there were requirements that contain, for example, up to 7 optional related smells, and weakness up to 10 instances, for example. So there were requirements like that. Of course, there were requirements that didn't contain that, so any of those smells. So they were quite good requirements in some cases. But this was good to flush out the problems. Then we have Marie-Jeanette and Emma that looked in detecting bad smells in industrial requirements, and they looked at 79 software requirements from various companies and governmental agencies. They found that some smells are detected more frequently than others. And actually we found it interesting is that the optionality smell was very, very problematic. And it was found in 870 instances of these requirements. So quite a lot of them contain these problems. Subjectivity, not that much, I would say. Yeah. Then I want to show these results regarding test specifications, which were test specifications related to both the functionality of the system, but also test specifications written in natural language related to security. So Anas and Josef did an investigation there, and they actually found more of the same problems like optionality. So many of the requirements contain optionality smells that were problematic. Not that much subjectivity or weakness related smells. Some of the test specifications were quite complex, so we saw that they were quite long, and actually in practice this might not be the best way to write test specifications. So even that can be discovered with NALABS. Yeah, so we had some data also regarding the number of findings per 100 words. So we wanted to see how many. So for example, in each test specification or test requirement written in natural language, we saw that, yeah, like from 6 findings per words to was the maximum 12 findings per 100 words. So it's a very simple tool, but it can be helpful in many cases. Yeah, so now I want to go to this part where we looked specifically on not only security, well, we wanted to identify only security requirements from 3 repositories. So we look at GitHub, NLRP, and Pure. So we look at this kind of example of requirements, security requirements. This is taken from Kubernetes repository, the only one with like they specifically shown the security requirements like that on GitHub. And yeah, so it will look like this. Like AI information system should be divided into separate namespaces. It is recommended to avoid the situation when the same maintainer is responsible for different namespaces. And this was related to authorization. So these are examples of requirements that are in the wild, let's say like this. So we looked through all of this, yeah, sources of information, and we looked through 362 different project repositories, out of which the majority were on GitHub, but we found also 46 in the NLRP and 79 were on Pure database. In total, we found 46 different, we call them specifications, containing 661 natural language security requirements. It's not that easy to actually find security requirements. So this is the sample size for our data, but it's still, I think, quite good. Yes. So we actually found quite a lot of problems, but I would say different from the ones on the other type of requirements, like safety, functional requirements. And so vagueness seems to be the most common problematic smell found. So 75% of the requirements contain 1 or 2 vagueness related problems. So this was very, very interesting result because we see a problem in having vagueness, in having security requirements that contain vagueness, and this is a problem when you want to use this for testing or for development. Yeah, so this is what I showed. I said before. And yes, with this results, we actually showed that the presence of smells in security requirements is a problem. And NALABS is useful in finding such problems early. And we also, of course, verified these requirements not only with NALABS, but also with human expert in security, so that we don't have only an oracle in this tool saying that this is a problem, but this was actually a problem. You can even take this example from the Gemini telescope, 2 security requirements from a specification. The requirement with an ID of was 273 showed the presence of optionalities. So it was, at the end, it says, and definition of a given user can actually do. It's a problem because when you use this kind of terminology, you just leave that to the interpretation of the user. And in this case, this was a problem. Yes, and the other one, yes, I think I'm not sure what was the problem with the next one. Yeah, maybe I have to check this, but yeah, it doesn't have an optionality problem, but it has a reference problem. Yes, it was, but it is not shown here because it's longer. So it has too many references. So it's not visible here because, yeah, I missed it. But you can see more example here. So for example, you had this requirement on the screen. You see the wireless access management. No, the requirements are network component specific and can be located as requirements for network components. What does it mean can? And that's a bit problematic. Or this capability may be provided. It's like, okay, who decides if this is maybe provided or not? So this we checked it also with the humans writing these requirements, and they said this is a problem. One other things that we looked on is some special words indicating problems related to security, and we saw that there are problems with under specification smells. So sometimes you specify the key, the access, the security policy, the attack, but you don't say which type. And this is actually a problem when you deal with security requirements. Yes, and lastly, I want to show some evaluation results regarding cost and effectiveness. So based on the evaluation performed by some industrial experts, when using NALABS, the estimate is that the reduction of, these simple mistakes, you would say, has reduced the spend time on creating requirements by 10 to 50%. So yeah, from 40, 60 hours for writing the set of requirements for a function to 25 hours. Yeah, but this might not be traced only to NALABS. So we know that some other aspects might influence the writing of this requirement. But I'll give you these numbers that I just got a couple of days ago from a company using NALABS. They tried it on their 179 requirements related to the brake system. I would say this is quite safety and I would say security relevant. And they found problems when they were writing the system level requirements for the brake system, and they found 21 problems related to vagueness, 3 optionality, 2 subjectivity, and 7 weaknesses. They were fixed, yeah, there was an escalation, which I always like to use that word, but apparently there was an escalation. Someone did something wrong. And but this is not to, yeah, this was used to fix this problem. So yeah, and what we're doing right now, we're trying to use NALABS in continuous integration. So the idea is to integrate this in, for example, GitHub Action. So when you commit requirements, the NALABS will be used to check these requirements and notify the engineers if there is a problem. And then you can deploy this if everything is okay. When you say deploy, is you can use the requirement later on. So this is what we plan to do in the next couple of months. So this, yeah, the two. With this I'll finish. I think right now we're still focusing on just some type of problems, but I think the whole idea is to use NALABS, extend NALABS, so that we could actually try to give, generate a better version of the requirement. So show that, okay, this is a problem, this is how you can write it better. So even having a pattern-based approach, like just showing how this a certain requirement can be rewritten in another way, that's something that we want to add. to NALABS. And with this, I'm done. I don't know how good I am with time. Excellent. Okay. Yeah, and I'm open for questions.
I just wonder, you mentioned data set,
Yeah.
600 something and security requirement.
Was it
Natural language? Yes. Is it accessible somehow? No,
this one?
Is it accessible somehow? Or
I for sure. I can give you. Yes, I can give you.
even you will.
Well, yeah. I mean, yeah.
But it's not that.
I can give you the data set, of course, because we extracted this information, so I can just give you that. Yeah. I think it's useful. Actually, this is a very good point. I think all these data sets are quite good for researchers. And I spend a lot of time doing this, finding. The students spend a lot of time, so I think it's good to use them. So maybe we should even create a, I mean, I need to check also, of course, if the requirements you can actually put, since they're open, maybe we can put them in a repository and say, you know, use it for experimentation.
Yeah, we also have the repository, actually you can check it if they're extra.
In VeriDevOps, yeah, in GitHub. Yeah, that's great. That's really great. That's a good point.
And also we harvested all of GitHub repositories and all issues, open and closed, so we can compare.
Okay, interesting.
Some of them actually not security, and many of security are not noted.
Exactly, I totally agree with you. That's a big problem, and this hinders the research that we do in security. That's for sure.
In Pure, we found more than 600, about 2,000 of security requirements.
Okay. Yeah. Wow.
I think we combined this promise data set or something.
Yeah, we didn't use here. Yeah.
Thank you for the presentation. Maybe I missed this part, but when you actually say that this NALABS 2 analyzes the requirement and detects the bad smells, based on what it will actually do this analysis? I mean, is there some frameworks that you suspicious or there's an algorithm?
Yeah, so there in some of the cases you have dictionary based, so you have a set of words or a set of like, or you have this word, then doesn't matter what it is, but then you have this problem. Then you have certain type of references. So in some cases you could say it's almost like a control F, but in the, you know, like you're trying to search for certain words. In other cases, we try to identify, for example, an adjective, which is not that easy. So in some cases, we need to use natural language processing to make sure that we understand that the phrase. So for example, sometimes you have as adjective as possible. So then you need to, it's not super easy always to detect that. Yeah, so we use natural language processing in NALABS also. The algorithm.
Number of words in a sentence.
Yeah, but that's easy. I mean, that's super easy to number of words. Then we have, for example, for the automatic readability index, we have a formula that we use from another, you know, from a paper written by some psychologist on how easy it is to read text, and that has been shown to work in practice. So we said, okay, this makes sense. We haven't done the research behind that, so we ourselves, but we trust them. So yeah, it's a combination of some simple searches what you could do yourself, and the natural language processing. But I think we can do more. We can, for example, formalize some of these requirements and try to see if there are requirements that contradicting each other, or apply some other techniques.
Do you work on the independence? I don't know.
No.
Requirement.
With NALABS, no. We do it. We try to do it in other tools, but not in NALABS. But it will be very cool to look at in NALABS, because you start with a version that is a natural language requirement. then you're trying maybe to formalize a bit the requirements, and then look, because once you have a formal representation, then you can look at this kind of problem, because otherwise it's super hard to do it on natural language. So yeah, it was a simple idea. Of course, there are other people that proposed this kind of techniques. It's not rocket science, let's say like this. But for me, it's not only interesting to do that type of research, but also try to solve some of the small issues that for some reason we never get rid of. So they always come back. Everyone thinks it's solved, but apparently it's not. So how can we have formal requirements when you cannot have, when you cannot write properly these requirements in native natural language? Yeah. Sorry, of course.
Yes. Another question. Based on your knowledge, okay, so we found several issues. Do you provide anyhow recommendations to kind of improve that? So
No.
Or
No, we don't.
I think it's kind of self-explanatory. You will get the feedback in seconds, but then you start to understand, okay, so this is actually vague, and that will change your way to do things. So I think it's actually easier to use the tool than start to read about it.
Yeah, yeah.
Okay. So you think, so you say, so you try to reformulate and check whether your numbers are better than previous ones.
Pretty much, and then when you more or less practice, well, then all of a sudden you also have more readable requirements. So, of course, first you think it's simple. Now I don't need the tool, but I should learn something, and that's even better.
Yeah. But I think it will be cool to recommend changes to the requirements. You know, like when you have the spell checker, and then you say, oh yeah, maybe you should use this. Yeah, exactly. So, I mean, it's a tooling issue. I'm pretty sure we can commercialize maybe this kind of idea easily. Maybe not by me, but yeah. But I think that's a good point, and I think we should have some. We should be, because yeah, I think this makes sense if you think about it. It will, for example, if you can recognize, maybe you can split the requirements, so you see immediately, like from the sentences, that these are two different. They don't actually talk about the same functionality. And you say split them up. Maybe you can split them, and then that's it's a recommendation. You don't have to do it.
But it will simplify testing.
Yeah, exactly. Yeah.
Another idea that I had, so okay, we have a feeling that requirements get better. So I think it requires also some kind of empirical study when you ask people, please compare this and that, which one is better one.
Oh, okay. Yes. Yeah. Yes.
Yeah. It's kind of self-fulfilling truth right now, because people kind of just spending just a bit more time trying to spell requirements, so they kind of convince it's clear one. But is it really clear?
Yeah, that's a good point. And this is very, it's not easy to measure that.
I mean, the empirical study
Yes.
before, like original one corrected. Do you think you feel then you can validate the numbers by the psychologist in the requirement? Yeah. You need a proper controlled expert, like an experiment, to evaluate this. We should talk about this then.
And one more question. In companies, usually they have some standards. For example, in API, if you have a standard when you write the requirements.
Should.
Yeah. So if we recommend some suggestions to write the requirement, how we can check if it's testing, if it's that standard or not?
That's a good point. I mean, we don't do any, we didn't look at, well, we identified a set of words and problems based on certain standards. So there, like you have the ISO 26262, I think, that, and there is the requirement, there's some requirements engineering standards that do some recommendations what might be the problems, and you should avoid doing this and you should do that. So we use that to populate the dictionaries we have. But we leave also the option for people to add their own words that they think.
But
But the safety standard is very soft, I would say. There is a requirement stating that the requirements shall be clear. Doesn't help. I mean,
Yeah.
Yeah.
So just to do this example, we should run NALABS on this standard.
Yeah, yeah.
makes sense.
Yes. Yeah. I could do that. I could run it tomorrow. Let's see. Well, tomorrow is Saturday, but I will run it on Monday. Yes.
I think this is very useful. But I'm wondering, I mean, do you use any lexical databases to establish syntactic and semantic relations between the words? Because if you say this requirement should be clear,
Yeah, then it's
what is the vagueness coming from?
Yeah, I mean the vagueness in
What definition? Why should I qualify this as vague? Based on what?
Yeah, I mean vagueness is many papers are identifying this as an indicator of quality problems, and then they suggest some lists, for example, of keywords. So, for example, you say may, could, has to, have to, might. I mean, even this, a very simple check, might. If you use might in a requirement, most likely, if you want to implement that requirement, you fail. What do you mean might? I mean, it's like, this is not clear. So this is clear. These are the things that I think the first
There
things.
are the sources of vagueness,
Yeah.
which I think are very prevalent from what I've seen in industry, and I've seen many requirements.
Yeah.
And it's also, the source also comes from when logical operators that are translated in language, like and or are used in a way that is like inconsistent with their definition.
Yeah.
And you don't know the scope of operators. And this, I think, is very important when you have should be smaller than minimum, greater than minimum, and that, and this or that, and basically the intentionality is different.
Yes.
Right.
And I totally
so
agree.
depending how you put the parentheses, you get one requirement or the other.
Yes, I totally agree, and I think this is something that I have I co-supervise a student, Salman, who's looking at this different sources of vagueness, and he's trying to improve the tools so that we take that into account, because we don't right now. I totally agree with you. What we do is one of the simplest checks that you can do from vagueness. You have, especially for vagueness, we have a dictionary. Because it's hard to do. Well, it's hard. I think it's not that straightforward to do it, and especially you can do it maybe for English, but you don't do it for other languages. And I totally agree that the different sources of vagueness should be taken into account. Otherwise, we're not really checking for.
That's a quick check. And
This is a quick check, but
I think to help come from going deeper.
Yes.
And then these kind of things which actually can impact right away.
Yeah.
The correctness of even of testing or the length or everything you're doing with respect to verification could be impacted for this, because you can get simply wrong requirements.
Yes.
Not only unclear or incomplete, but wrong. And this is important. So the intentionality is not captured because people do not use these words correctly.
It could be that, for example, we saw that a source of ambiguity and vagueness is under specification.
Oh, sure.
How would you detect? I mean, and then that's another source of vagueness, which should be like you should be able to find under specification with some. It's not easy. It's not about the keywords.
But we can talk because I worked with Mälardalen on this.
Yeah, I know that you worked with Mälardalen.
Yeah, so I worked a lot on this, and